Central tendency is a statistical measure to determine a single score that defines the center of a distribution. And of course, we want to find a score that's most typical or most representative of the entire group. Generally speaking, we're talking about a mean or a median or a mode. And sometimes those three are all the same thing. So look at letter A there, the graph there. As you can see, the mean and median and mode are all the same in a normal distribution. The mode is the tallest stack, that's 5. It's also the median, which bifurcates the distribution exactly in half. And of course, the mean is 5. Well, that's easy to interpret. Letter C is a little more complicated, I guess you could say. It is true that 5 is the median. As you can see, it's the number that bifurcates the group. It's also the mean, but could you describe in letter C that 5 is the most representative number when there are no 5s? That's a tough one. So maybe the median would be the better number to cite there, although that's a tricky one. Letter B, you can see that that's a strong negative skew. The numbers are stacked up at the high end. And in that case, the mode is 8 in any case. And by the way, in letter C, the modes were 2 and 8. There was a tie. But the median and the mean are less clear. And we'll get into that, how to handle skewed distributions and also how to handle normal distributions when citing a measure of central tendency. Let's speak of the mean first. That's the most obvious thing. There are subtle differences in symbols. The formula for the population mean is mu, the Greek character, equals the sum of all the values divided by capital N. When we're talking of a population, it's capital N. In a sample, it's capital M instead of mu. The sum of all the values divided by lowercase n, and generally speaking, is italicized. So a subtle difference there, but we like to remain faithful to the symbols, and I always will in our problems. So for a population of 4 scores, 3, 7, 4, and 6, of course, I would just add those up and get 20. There are 4 scores, and that would yield a mean of 5 for the population. Now, you might ask yourself, how will we as students know whether it's a population or a sample? I'll have to tell you. I won't be subtle about that. There's no way to be coy. I must just essentially volunteer whether it's a population or a sample, and I always will. And you can see capital N up there. Let's take characters for a sample. Suppose that 6 boys from another example decided to sell their baseball cards on eBay. If they make an average of $5 per boy, what's the total amount of money for the whole group? What I can do here algebraically is to solve for any number that's missing. So the question here they ask is, what's the total amount of money? I know that there were 6 boys. I know that they made an average of $5. And if I left that $30 up there as X, couldn't you sort of cross multiply and figure that out? X over 6 equals 5. And of course, we would know that's 30. You can just sort of act as a detective. And you might remember cross multiplication from algebra. It would be 30 times 1 equals 5 times 6. Or X times 1 equals 5 times 6. And of course, you can solve for that and get 30 pretty easily. We always use this metaphor of a seesaw. The mean is balanced at that middle point, and that's is where we place mu. So if I have an array of numbers, even though this array is kind of irregular, I've got 1, 1, 1, 2, 2 6s, and a 10. That mu is sort of at the balance point. So we use this metaphor of a seesaw, and we'll always do our best to get the best measure of central tendency that we can. And a seesaw is, I think, a good metaphor, where the fulcrum is, if you will. So I would like to get into some particulars of the mean here now with respect to manipulations. And we'll start off in the next clip with what happens when we change a score.